Right now, bearing roll number 210118068, and this PPT is being presented under the course coordinator G Raju, Assistant Professor, Civil Department. And today's my PPT presentation is on the topic energy audit of facilities and optimization of energy consumption. Now we'll going to see these topics where we will see the introduction, types of energy audit, steps in energy audit process, energy consumption analysis, optimization techniques, and benefits of energy optimization. Coming to introduction, what does energy audit mean? The definition is as follows. An energy audit is a systematic approach to analyzing energy flows and identifying opportunities to enhance energy and efficiency in facilities. And how it is important? It is because for the reduction of energy consumption and for the operational costs. And it promotes sustainability and environmental conservation. And enhances energy management strategies for long-term benefits. Here we can see the image. And going to next slide, where we have objectives of energy audit, where we identify potential energy saving measures by analysis of current energy usage and discover inefficiencies. And next, improve energy efficiency by maximizing the performance of energy systems to use less energy for the same output. And next, minimizing environmental impact, that is by reducing carbon footprint by optimizing energy usage. And next, enhancing cost effectiveness, that is by lowering operational costs through how the objectives of energy audit is being presented. To the next slide, types of energy audits by university, where they presented the types of energy audits in three categories: preliminary, in general, and detailed. We can see in preliminary energy audit, the quick and simple, and it focuses on major energy inefficiencies, and which also provides a rough estimate of cost savings. And coming to the general energy audit, where within more detailed than preliminary, includes utility bill analysis, and it identifies viable energy saving measures with financial analysis. And coming to the detailed energy audit, which is a very thorough kind of energy audit, where we see comprehensive covering energy inputs, processes, and engineering solutions, which includes sub-metering, monitoring, and optimization plans. Here we can see the key systems audited are boilers, HVAC, power distribution, compressed air, and motors. And also energy audits reduce cost, optimize consumption, and improve efficiency. And here I presented the comparison table between the types of energy audits for the easy understanding. And coming to the next slide, where energy audit process, how it goes on, we'll see in step-by-step guide, where the data collection and analysis takes place. We'll see how it takes place. We first gather energy consumption data from utility bills and records and meters, and conduct site inspections to access equipment and operations. Then we go for use monitoring tools to collect real-time energy data. Then we go for analysis, which tends to establish baseline consumption. And this next step in the energy audit process is identification of inefficiencies. Here we compare energy usage with industry benchmarks, and then we detect for identifying inefficiencies in operations and maintenance schedules. And then we access thermal losses, leakages, and power factor issues. And the third step in an energy audit process is development of optimization strategies. Here we implement energy saving measures like automation and efficient appliances. Then we modify processes like optimize load distribution and renewable energy use. Then we encourage behavioral changes, turning off unused equipment policies. This point, I remember my mother saying, whenever I go home from one room to other room, I generally forget turning off fans and lights. That actually the mother's concern is this point only, encouraging behavioral changes. We can learn from our mother. And the next point is perform cost benefit analysis and set action plans with targets. And the next slide, I explained about tools and techniques for energy audits. How, with what equipments and tools we do this energy audit. Here we have tools like energy meters, which measure power consumption of equipment. Here we can see the meters. Generally, we are aware of these meters in our house daily life, where the building people come and they just check this meter and they bill the power consumption. And thermal cameras, as we can see here, uh, as we can see this is thermal camera where they detect heat loss and insulation defects. And also in tools we have data loggers which record energy usage over time for analysis. And next techniques are, we track energy consumption patterns to identify inefficiencies. And coming to thermal imaging, within the technique, we use infrared cameras to detect overheating and insulation failures. And going to next slide, where I took the energy consumption patterns in different sectors like residential sector, where we use it's in mornings and evenings when people wake up and return home, and heating, cooling and appliances like ACs, refrigerators, water heaters, which are major consuming gadget daily home appliances. Like if we take an example, in summer AC usage increases, leading to higher power bills. This is a kind of energy consumption pattern we generally see in our residential sectors. And next sector is commercial sector, where higher energy demand during working hours like 9 a.m. to 5 p.m. and drops after closing. And lightning, HVAC systems and office equipment consume the most energy. And here example is a shopping mall uses maximum electricity during open hours due to lights, accelerators and cooling systems. Yeah. Next sector is industrial sector, where high and continuous demand of energy consumption is seen because industries operate in shifts. Major energy usage in heavy machinery and furnaces and motors. Example, a steel plant runs 24/7, consuming massive energy for furnaces, requiring energy optimization. Key influencing factors are load demand, electricity demand fluctuates based on time, season, and sector needs. Example, we saw factories use more power during production shifts than breaks. And equipment efficiency we can see as inefficient or old machines waste energy, leading to higher cost. And example we can see is replacing old bulbs with LED lights reduces consumption. And diving into the case study, here I took the energy optimization in Infosys Bangalore campus, where the scenario we can see is a kind of challenge in the Infosys they took, where high energy consumption due to 24/7 HVAC lighting, servant equipment and lack of automation. So for that, how did they go went to overcome this situation? Here they did the energy audit findings, where overuse of HVAC, ACs ran at full capacity all the time, and inefficient lighting, fluorescent bulbs wasted energy, no automation, equipment was stayed on even during off hours, high data center load, excessive cooling demand, and the optimization strategies implemented. The solution part which we can see in this Infosys Bangalore campus scenario is
Hello?